We are surrounded by invisible signals all the time. But have you ever stopped to think about how they actually work? Well, today, we're going to crack the code on a secret conversation, one that's happening right under our cars. Yep, we're talking about the secret language of your tire pressure sensor. Let's dive right in.
So, we're talking about a tire pressure monitoring system, or TPMS for short. You've got these little sensors inside your car's tires, and they are constantly broadcasting really important info. But here's the thing, they aren't just yelling out, hey, 32 PSI over here into the air. Nope, they send a coded message. So the big question is, how do we actually listen in and, understand what they're saying?
And to figure that out, we're going to follow along with a really cool project that does exactly that. The mission here is pretty simple, but actually really powerful. Grab that raw wireless data straight from the tire sensor and then turn it into something useful, like a real-time display with safety alerts. We're basically building our very own smart dashboard from scratch.
Now, what's so cool about this whole thing is just how simple the hardware is. Seriously, all you need is a tiny microcontroller that has a screen, in this case an ESP32-C6, the Bluetooth sensors, of course, and a simple little buzzer for the alerts. This isn't some crazy expensive lab equipment. It's stuff that pretty much anyone can get their hands on.
Okay, so we've got the hardware, it's all ready to listen in. But, and this is the big catch, the sensors don't just send the data in plain English. That'd be too easy, right? They broadcast these encoded packets to save on battery life and data space. So, if we want to build our system, we've got to become code breakers first. We need to figure out the sensor's secret language.
And here it is. This is what the sensor is actually sending through the air. I know, it just looks like a totally random kind of intimidating string of numbers and letters. This is the secret message we have to crack. And buried somewhere in this big hexadecimal mess is the tire pressure, the battery level, everything. So, the question is, where do you even start with something like this?
Well, luckily for us, it's not total chaos. Bluetooth Low Energy devices, BLE, they all follow a standard format. It's called the advertising data structure. The best way to think about it is like a set of rules for packing up information. Every little piece of data gets bundled into a block that tells you three things: how long it is, what type of data it is, and then the actual data itself. And that right there, that's our first key to cracking this code.
Okay, so using that structure, we can take that long, scary string and break it down into 4 manageable chunks. First, you've got flags. They just set some basic rules for communication. Then there are service UIDs, which are kind of like addresses for different functions. You also have the device's name. But the one we really care about, the juicy part, is that third one, manufacturer-specific data.
All right, so this is the crucial part. This manufacturer-specific data section, it's marked with the type 0xFF. Think of it as a special, totally flexible field where companies can just stick whatever custom data they want. It's basically the treasure chest. This is where our sensor is hitting the good stuff. The tire pressure, the temperature, the battery life. All we have to do is find the right key to open it.
And after digging around in that manufacturer data, we find it. Our big clue. These 2 little bytes right here, 56-0C. I know, it doesn't look like a pressure reading. Not yet anyway, but trust me, this is exactly what we've been searching for. This is the encoded pressure value. Now, all we have to do is decode it.
So, here's rule number 1 for decoding this thing. The data is stored in a format called little endian. It's a super common way computers store numbers, but for what we're doing, it just means one simple thing. The order of the bytes is flipped. We literally have to read it backward.
So, we take our 56-0C and we just swap them. Simple as that. That gives us 0C56. It might seem like a small change, but it's an absolutely critical step. We've just put the bytes back in the right order, and we are one step closer to getting a number that actually makes sense.
Okay, next up, we convert that hexadecimal value, 0C56, into a regular old decimal number. And that gives us 3,158. Now, that's definitely a number, but it's for sure not a tire pressure. Not yet. We're missing one last final step.
And here it is, the final piece of the puzzle. See, to save space and avoid having to send messy decimal points, sensors will often scale up their measurements. They'll just multiply the real value by, say, 100, so they can send it as a nice, clean, whole number. So all we have to do is reverse that. We just need to divide our number by 100.
And boom, there it is. 3,158 divided by 100 gives us 31.58 psi, a perfect, beautiful tire pressure reading.
We did it! We took this mysterious little piece of a long hex string, applied a couple of simple rules, and we uncovered the secret data that was hiding inside all along.
So now that we've cracked the code, the rest of the project just kind of falls into place, you know? The logic from here on out is pretty straightforward. You figure out what essential info you want to show, you design a nice, clean user interface for the screen, and then you write the code that tells the ESP32 to do all these decoding steps in real time and keep that display updated. So just take a step back and look at this whole journey. We started with this totally cryptic signal, right? That little 56-C, buried deep inside a long string of code. And just by understanding the structure and applying a few simple rules, we transformed it. We turned it into a clear, useful, and honestly a potentially life-saving tool. A display you can read that shows not just pressure, but also battery levels and warnings, all in one quick glance.
It really makes you wonder, doesn't it? The air all around us right now is just filled with these kinds of invisible conversations happening between all our devices. So the question I want to leave you with is this. What other secret data is flying all around you right this second, just waiting for someone curious enough to come along and crack its code?